We are at Platform X, how SMPH implemented a secure data enclave. Our presenter today is Mike Collins. We will hopefully have some time for questions at the end.
And my apologies as well. So my name is Mike Collins. I'm the Senior Director of Research Coordinating in the Office of Information Informatics and Information Technology at the School of Medicine. I'm here to share our story today about Platform X, which has been about a 4-year journey. What is Platform X? So it's a Azure cloud-based, HIPAA-compliant computing environment. It's because of its nature of being in the cloud, it's very scalable, it's flexible. We can provide any number of computing and resources, nearly unlimited amount of data space. We've designed this in a way that is meant to keep the data within the platform. So we bring our researchers and their analytics and their analysis into the platform so the data remains there where we can protect it. Each project or the PIs are provided a purpose-designed computing environment for them. So it's designed to meet their needs. We took an initial approach that was kind of more of a lift and shift approach. So when people are used to doing work on either their own computers or they're used to doing work on servers that are provided by departments. So we wanted to provide them a similar kind of experience rather than trying to get them to use new tools or more web-based tools initially. So the current state of Platform X right now looks a little bit like this at a very high level. In the middle is what we call a data hub. That is where all of the data lives. And all of the sensitive data. As you can see in the bottom, we built this with our collaborators at UW Health, and so we have, and I'll talk about it in a minute, a data sharing agreement with them that allows us to access data within UW Health. So they share the data from their electronic medical record via databases called Clarity and Caboodle, which are Epic data sources. We also get HL7 messages. HL7 is a messaging standard that's been around forever. It's text-based. It's not awesome, but it's how we often exchange information with healthcare organizations. So we have a team called the CURDS team, of the Clinical Research Data Services team, who operates in this environment. They use a tool called Data Factory. It's an Azure product. It's a web-based ETL tool, so much like Informatica, if people are familiar with that. They take these data, they transform them, they put the data into databases, into a data lake, and then from there we share out that data. So in the top right-hand corner, I'll get a little more into this later, is what we call our data science dry lab suites, and that is where we can deliver data sets to our researchers, and we provide them, again, their compute, storage, databases, backups, et cetera. The only approved way to get data in and out of this platform is via Globus. So we have an audit trail there. We make every user of our platform sign an attestation that describes what they should and shouldn't do with this platform, including anything that they take off the platform has to be approved to be removed. So it should not contain PHI unless there's a data transfer and use agreement in place that allows that. So most of the things that are taken off are more summary images and things like that that they want to include in a publication. For those, we have some researchers that are building data commons, and we're in fact building data commons as well. This is meant to be an area where we bring data from multiple different locations, we bring it all together, we provide our researchers tools like Airflow, which helps them kind of develop their own ETL type things. We provide visualizations like Power BI, and then we allow collaborators into that environment so they can do their analysis against these larger data sets. We also use it to share out data. So we have a collaboration with All of Us, which is a nationwide research project. So we transform this data and then we push it out through this environment. We also are doing web application hosting. And right now we have two primary applications that are hosted there. One is CBOW Portal, which is a cohort discovery tool for genomics data, genetic data. So people can find people with rare diseases and helps our researchers identify people who may be eligible for clinical trials. And then we have REDCap, which is our research electronic data capture system. So it does surveys, data collection forms, workflows, a whole bunch of different things. We use it to collect a lot of the data at the School of Medicine. And then we use something called Azure Functions, which is a serverless, way to create an API or to run code. And that does a bunch of integrations with us. And these often are very inexpensive. You're only paying for the little bit amount of time that you're computing. You're not putting up dedicated resources. It spins this thing up, it executes the code, and goes away. So why did we create this platform? And I think there were a number of reasons, but two primary reasons. One is our user UW Health, our health system partner. They wanted to know where their data was, and honestly, we couldn't tell them. It's everywhere, right? It's on laptops, it's on desktops, it's on servers and departmental storage and file servers, it's in clouds, it's in personal computers, it's in collaborators' data. So they asked us to do something about that, and then they want to know who's securing this, right? And how is it secured? And we had 20+ environments within the School of Medicine alone. It doesn't include all the other collaborating people that we work with across campus. Who has access? Sometimes we know, sometimes we don't. Who's it shared with? Again, challenging. So the other party in this is our investigators, our researchers. We ask a lot of our researchers, and it's unfair, right? I mean, we ask them to be experts in privacy and security and compliance, whether not just HIPAA compliance, but FDA compliance and the things you have to do for the Center for Medicare Services, et cetera, et cetera. We ask them to go find their own computing. We ask them to, and they may work with IT departments to do some of these things, of course, but we're asking a lot of them. So what we'd like to just have them do is do research and let us handle all this for them, right? Like, you don't have to run security. You don't have to worry about all these other things. Just do your research. And so the longer term vision here is we want to be able to support the full life cycle of biomedical data. So that's not just our clinical data, it's genomic data, anything else that might be of interest to our researchers. And so we hope to provide a suite of tools, right, that supports this whole life cycle from designing and planning out their research all the way to publishing and reusing those data and those research that they've done. So that's going to include not just the technology, but procedures and examples and training. And we're not there yet, but this is stuff we're all still working on. And then integrate these tools to the greatest extent possible, right? I mean, often we give a bunch of people a bunch of disparate tools that all work independently, and we make them kind of copy and paste, move things between things, but we'd like to provide them a nice user experience. And I did borrow this graphic from Harvard, so I'll put an acknowledgement there. So now I'll get a little bit into how we created Platform X. So as I mentioned earlier, one of the first things we did was we established a data sharing agreement with UW Health, and that established a research policy steering committee. So they're members of the cybersecurity, privacy, other executives within both the School of Medicine as well as UW Health. It allowed for the creation of a research data repository. So again, we're pulling all this data, we're transforming it and making it more accessible and usable by researchers. And by putting that agreement in place, we're able to pull all of the data in with some exceptions. There was an agreement with UW Health that PHI must only be accessible within improved environments. We're still working on that, but that is what we're working towards, Platform X being one of the primary place where we can put that PHI right now. And we established rules for how we can share data. Overall, our approach, again, was to create this HIPAA-compliant environment. We took a hub and spoke architecture to this. So we have a central hub where we have our connectivity, our VPN connections to UW Health and the University of Wisconsin. All of our network traffic goes through this, so we create various subnet networks that are specific to either projects or researchers. All of that's controlled through a firewall. We have centralized services for logging, for licensed servers, et cetera. We took a DevOps approach, so this is where infrastructure is code, so everything is code-based. We're building a data center in the cloud with code. There's no hardware that we touch. Everything is version controlled, and all that. And we want to support a diverse set of research computing needs through a flexible and tailored approach using what we call bricks. My team loves Legos, and so we take that analogy. Here's a visual on what the hub and spoke architecture looks like. Again, I think this is a really important feature. So that Azure firewall that's in the middle of this thing is a virtual firewall. It's, again, all code. We write the firewall rules in code. We review those code. They get committed. It's one of our most expensive pieces of all of this. We don't want to have to replicate this more times than we need to. And then everything behind it takes advantage of it. Not the only security feature we have here. Our DevOps. So big fan of automation. Automation means repeatability, consistency, and good security in general. We use Terraform, which is our infrastructure as code. We use Ansible as a configuration management for doing the installation as well as configuring of our servers. We have this continuous integration, continuous deployment pipeline, or CI/CD pipelines, where the DevOps engineers, many of them are, guys, they check in, they write their code, they check it in, it gets built, they run through some tests. You know, when it doesn't work, it destroys the whole thing. They rinse and repeat as many times as they need to until the code is working. And they do this off a feature branch. So we have a production branch that tells you exactly what we have in production. They create a little feature branch, they do all that work. Once the things are good, they do a pull request, and they have a peer of theirs review that code. It goes through the same kind of process. We check it. There's a plan that's built to tell you exactly what's going to change when this gets run. Then it gets approved by their peer, who can review that plan, look at their code, make sure it's all good. When they approve it, it gets built and deployed in our staging environment. So we have a replicated test staging environment that is similar to production, with just fewer resources, less cost. And then we have our QA specialist who goes in, tests everything, makes sure it's working as expected. Once it is, another pull request is done. Now a manager who has no access to who doesn't do the code, doesn't have access to anything else, reviews that, approves it. Same process happens in production. And then that gets merged back into production branch. Again, the production code branch represents everything that's currently in production. Building bricks. So we have three basic types of building bricks. One is the resource bricks, which are reusable Azure resources. So it's our compute, which is often virtual machines, storage, disks, databases, networking, firewalls, et cetera, et cetera, et cetera. We have software bricks, which are all of the software that we can install, update, remove, patch, et cetera, to be automated. And then we have our compliance bricks. These are all the security and privacy features and tools that we use to ensure that this data stays protected. As far as assembly goes, I mean, it's kind of an analogy, sort of works. But each brick is, again, a basic building block, right? We can build these templates. So much like a Lego thing that says step by step, this is how it's done, although we get a little more customization to those. We can provide input that makes that environment unique, but then it runs through our DevOps pipeline, generates the same thing over and over and over again consistently, right? So all of the settings are done consistently. I think a lot of people right now, when they use the cloud, they're using click apps, so they're clicking through screens. It requires everybody does it exactly the same time every time. What happens when something changes or you do something different? Someone's got to go back and click all those things again. This code automatically does that for you, right? Ensures consistency. So one of the first things we did was create these data science dry lab suites. So this is where you tell us what you need. We can give you one to many, Windows, Linux, both, command line, GUI. Again, data goes in and out only through Globus. We provide them cloud storage that gives them more data space than they'll ever need. We provision local disks, which are another object within this environment. We can provide them databases. There's backups for everything. Again, we handle the security, both privacy and security, and we can install whatever software. I don't know what our software suite's up to. It's maybe 60 different applications. I don't think we run too often into new things that we need, but when we do, we're able to accommodate those as well. So just to give you an idea, there's often rumors that, cloud's expensive, and it can be, right, if you don't do it right, and we're always trying to drive and find ways to save money. We even have an agreement with Microsoft that gives us about 13% off list prices. But here's an example. So if I was a researcher, I needed to do analysis over a 3-month period using a virtual machine that's got 8 virtual CPUs, 32 gig of RAM, decent sized disks, which I think all of us agree was a decent sized computer. Say they have 25 gig of raw data, they do this analysis over 3 months, 480 hours, and they have a final data set that they need to retain for 70 years. It's 50 gigabyte, for example. That costs them about $300 for 10. And that may be less because this is pre some of the discounts. So this doesn't have to cost a lot of money. There is some ways they can control the cost, and that's by starting and stopping the machine. Now that's only the compute. The disk and storage use is ongoing. It's just for as long as that's running. But again, it doesn't need to be expensive. And most of our researchers spend anywhere between $30 and $100 a month, typically for their research environments. Some of them have very large environments where they spend thousands a month, but it's dozens of VMs and a lot of storage and a lot of complexity. So security is, again, one of the primary reasons why we do this in the cloud. We can do more to secure this environment, we can do honestly on-premise. We do all the standard stuff, Qualys, AMP, local firewalls, CIS controls, all those things. So I'm trying to highlight some of the unique things that we're trying to do within here that maybe is not done everywhere. So one of those things is role-based access, right? I know maybe I was probably all through this, but so can we give everyone's assigned minimum privileges, right? There's only a limited amount of things they can do appropriate to the environment. No one has access to production natively. You can't just log in and immediately go into production and change anything. We intentionally set it up so the DevOps engineers don't have access to the data or the VMs, so they can manage the attributes about the VMs and about the data, but they can't see the data, right? So we're trying to protect that and leave that for our researchers. The key thing that enables all this is privileged identity management. It's an Azure feature. It allows our DevOps engineers or our testing person to elevate their privileges to appropriately scoped, so they can just pick a role. It's appropriate to what they're trying to do, scope it to the amount of time, to the specific resources that they need. Again, that manager or the approver has to approve their access before access is granted. There's an audit trail of all of the approvals, requests, et cetera. And this is helping us protect us in the event that your computer gets compromised, your user gets compromised, your password gets compromised, your MFA gets compromised. We still have this. So there's still another human that has to get involved before someone's able to modify anything in production or access anything. So similarly, separation of duties. Again, like I said, developers, they write all the code, they do the pull requests, they review each other's code. Our approvers, which is the management, reviews those codes. That code, they don't always know what's happening, but it's again just a human involved, and another human with a different set of roles that's involved in promoting that code. We again use our quality assurance person to test this stuff as if they were users and validate all our configurations and settings. And then we can bring in auditors from our cybersecurity team to review our environment, make sure that we're doing all the things we say we're supposed to do. We just need read access, really. We try to do defense in depth. So we use Azure Defender, which has got a whole bunch of features. There's just too much, really, that they do. Those are some things there. And they have unique offerings for each of these different types of resources, so servers and storage and containers and databases and key vaults and app service. So storage, for example, they've recently added malware detection in there. So even if something got into our environment somehow, there's still, our Defender would pick up that there's a malware on the storage, not on the drives, and clean that up. And then there's another interesting feature called Azure Policy, where you can write policies or use the ones out of the box that either enforce things that we want done. So make sure that Defender for whatever servers is enabled on all of the servers that we deploy in our environment. And so if we forget, for whatever reason, it automatically applies it. We can also monitor to make sure that things we expect, the settings we expect to be on, are on, and alert us when they're not. We also try to minimize our attack surface. So you won't find us anywhere on the internet. We're running in the cloud, but there's no SSH ports open. There's no RDP open to the internet. All the traffic that the communication between all these servers, besides being encrypted and all that, is all happening privately within the internet, within Microsoft's data centers. Never hits the internet. The default for most of these cloud providers is it goes over the internet. Public IPs. We're using private IPs. We use Azure Bastion, which is a fully managed platform as a service offering from Microsoft. Basically, you create an SSH tunnel from your PC to Azure, and all that traffic goes over that tunnel. So if you're doing remote access that way, you can also access things via the web browser. Another important feature is conditional access. So anytime you're accessing Platform X or any of the supporting things like DevOps or Power BI, we ensure that everyone's coming through the SMPH VPN IP address. And in our VPN, we've set up HIP checks or some secure endpoint checks, and it's just not ideal, but it's at least a check that things are reasonably secured on that device. Someday we'd like to get to Intune, where we can do a little more advanced checking of what the devices themselves. Again, also requires MFA anytime. It also is smart enough to know that if something's suspicious here, it's going to prompt more often for an MFA in your passwords. We try to do everything secure by default. So our Terraform modules, which are these reusable things, we designed to be secure by default. So we set it up so that they're secure by default, and you have to override our security in order to change that. And then again, it gets reviewed. It's more obvious that something may have changed and may have been overridden. Again, CIS benchmarks are applied to all the virtual machines. Exceptions to those are documented and approved. We use deny all by default in our firewalls. We allow very little out bound. So even if, again, something gets compromised, can't talk home. Again, all those firewalls are managed in Terraform. Again, limiting data egress, firewall, Globus the only way in and out. We do permit data GitLab, just because we want to have our code managed somewhere. This is an area that we're struggling with because it's already happened. People have egress data accidentally. PHI ends up in GitLab. Now we got to clean it up. So it's an issue, but we have to do something. But we don't, for example, provide access to GitHub because it's too easy to egress data to now something we don't even control. At least the campus GitLab, it's under the university's control. We have some more flexibility there. Can't go to Box, can't go to OneDrive, can't do the research drive either. So that's all that. I'm trying to rush through this. We're doing all right on time. Want to allow a little time for questions. So just to give a feature on what we're working on right now, AI, LLMs, ChatGPT are all the rage now, right? But no one's got a great solution for this. But we are using OpenAI so far, still just with public data, because they have some additional privacy that OpenAI, the company, doesn't have. So basically, Microsoft's not using that's using our data at all. Doesn't use it for their model development or anything else. We've also we requested and have been accepted to exempt ourselves from abuse monitoring and human review, which is something else that they built in as protections for them, but that would mean our data may potentially be viewed by people who shouldn't see it. So we've asked for that to be removed, all in preparation for us to be able to support restricted or sensitive data in these models. Again, it supports all the models, even the most newest ones, the GPT-4o. We've been working very closely with Microsoft to evaluate Microsoft Fabric, which is a newer software as a service platform. The idea is one lake, all your data is there, accessible to different types of roles. They have a specific thing to deal with healthcare data solutions, very similar to what we were already building and I have built. But now that's something that we could potentially get from Microsoft. So we're working with that on them, and also looking at Microsoft Purview, which is a data catalog. So again, how do we make that data accessible and make it findable for other researchers who want to come along later, combine that with their own data, or repeat the research that we've done. So finally, this takes a village. These are my unsung heroes. This is a great team. It's probably one of the best teams I've ever worked with. We hire for smarts and skills, but I always say that we always look to hire people who play well with others, and this group is as good as anyone in playing well together. They share ideas, they challenge each other, they push each other, they learn from each other, and it's a great team to work with. And we hope to continue to expand that. Again, we wouldn't be able to do this without our partners at UW Health IT as well as do it, and with all the users and people who contributed to our success here in Platform X. What questions do you have? And I did plant a bunch of friendly faces in the audience too. But I do want to encourage, again, this is a community. We came here to share our story, and it was so that if there are things in this that you're interested in, all of the team, anyone on this previous slide page, I am confident will be happy to share more about how we've done things and what we did. I feel the same way. Feel free to reach out to me directly. I will take your calls. I will return your messages. Looks like we have a couple questions over there, Amy.
If you have one, go for it.
We're going to the mic.
Oh, thank you. All right. Mary Murphy from Research Cyber Infrastructure. So I'm still new to this space, and it's very cool to see when you're combining the data in like a data lake and then tagging it for kind of the data commons. How do you work with like the most sensitive data? So I used to work on Alzheimer's research, so I don't know if they're even part of this yet, but Alzheimer's or cancer research are kind of the stigmatizing type of data. Does that take extra work, or does that just end up in the same pipeline workflows?
So the exceptions to this are some of the really truly stigmatizing data, and those we do typically clean out, and they aren't included in most of this. There are researchers who work with that data, and so we tend to do special cases for them. So it's often not going to be data that anyone would have access to other than those researchers. And there's even limited access to any of us as well. I think there's some other questions. There's two in the second to last row.
All right. Yep, we have time, I think, for one more.
And I'm happy to take all questions later.
Hi, Megan Yaki from the School of Business. I'm wondering about your rollout and adoption. What kind of education or training have you developed for end users? Did you encounter any resistance from end users with this model, and how did you deal with it?
Yeah, there's always resistance to this kind of stuff. We created websites and had pages with some KB articles on how to do things. Sherry's in the back of the room. She does a great job trying to improve this. We've recently engaged our user support services team to help educate them, to give more hands-on help with getting in. Our biggest challenge is actually just getting them in. Once we get them in, it's usually fine. I mean, again, you got to work with the command line at the moment. It's not a super user-friendly interface. The bigger change is the money. Even though it showed you it's not expensive, people just don't want to spend anything, right? They're used to this not costing anything, but there's a cost, as we all know, to providing secure environments. We don't charge them for any of our engineers' time. We don't charge them for the security features that we have here. We're only charging them for what they use. But it's still work in progress. Training is an area definitely I would like to see us improve and increase on. So, again, I will be at the terrace this evening too, so happy to entertain any other questions there. It's a beautiful day. I wish we could be presenting outside.
Okay, big thank you for Mike, please.